Okay, so for number 6, it's set up like we saw yesterday. And yesterday we would put this first term in the house and this one outside. But this way is completely different from that. So we're going to actually, so x plus 2, this 2 right here, we're going to take it, turn it to the opposite sign, and put a negative 2 in like a little box like this. And then we are going to list out all the coefficients here, over here. So this negative 2, 5, negative 1, and 2.
Why is it negative 2 in the box?
Because it's going to be the opposite sign of whatever that is. Like if you were to put x plus 2 equals 0 and solve, then it would be x equals negative 2. Okay, so we listed out all the coefficients. Now we're going to draw a line right here. Leave space because you're actually going to fill in numbers there. And then down here, we're going to fill in numbers here. And what these numbers will represent is x squared, x, the constant, and remainder. And as far as why I chose x squared, I want one less. So this is x cubed. I need one less than that, which would be x squared. Okay, so now here's the process. We're going to bring down this first term, negative 2, and put it here. And then we're going to multiply this number in the box by negative 2, which would get 4, and put 4 here. And then add these two terms. And then multiply negative 2 by 9 to get negative 18. Then again, add these two terms. And then multiply these two. So negative 19 times negative 2 would be positive 38. And add this to get 40. Now what the heck did we solve for? Well, these are actually the coefficients now. So this would be negative 2x squared plus 9x minus 19, the constant, plus the remainder of 40 over x plus 2. So if we were to take this polynomial divided by x plus 2, this is the answer. Yes?
Can you just do it the other way?
No. Well, I mean, you could, but you're not going to want to. Well, the next page you can't. So that's why I'm teaching you this way.
Do you just have to memorize like what number?
Right. So that's why I was hesitant to introduce it yesterday, because these hacks seem easier. When it comes down to it, like, it's hard to remember all the little steps. Like 2 months from now, it's going to be hard to remember the steps. So like if you're taking the SATs 2 months from now, this process would be a lot easier to remember than this one. But we do need this for the next page. So that's why I'm introducing it. So it might seem weird the first time, but by the time you do it 2 or 3 times, it gets easier, I promise. Okay, we're going to do one more example just like this. I'm actually not going to use number 8. I'm going to use different numbers. Here I kind of feel, if you have the space open, use it. I obviously wrote in it. Okay, so the problem that we're going to do next is actually 3x cubed minus 4x squared plus 2x minus 1 divided by x plus 1. Okay, so setting it up like we did before, we're going to put a negative 1 in the box and then list out the coefficients. If you had a missing term here, then you would fill in a 0, but we don't have a missing term. So 3, negative 4, 2, and negative 1. Okay, now we do the same process. Bring down this 3. 3 times negative 1 is negative 3. This 7?
Yeah.
Negative 1 times negative 7 was positive 7. Added them to get the 9. 9 times negative 1, negative 9. And then writing this out.
Did you get the negative 9 on the right side?
Oh, this here? Negative 1 times 9 was the negative 9. Okay. Now we're going to move to the next page. Continuing this process. If you're starting to get it, great. If you're not quite getting it, that's okay. We're going to practice it like more. Yes.
So,
You can use this instead of yesterday's.
So like we can choose either one.
Yes, as long as, so it only works when you don't have a coefficient in front of the x. So for some of these where you had the 2x minus 1, you would have to do the long division way. But if you look back at yesterday's homework, there's a lot of them that are just x plus 2 that you could do. Yep. Okay, next page. So here's where we're actually starting today's lesson, just using that skill. Factoring polynomials. Okay, so in this case, the remainder theorem, the remainder when dividing x minus a is p of a, so when evaluating for a, the remainder after dividing x minus a is the answer. So for these, whatever the remainder is going to be the answer. So for 1, they said x equals negative 5. That negative 5 is what's going to go in our box.
You're going to switch it because it's given to you.
Okay, now we list out the coefficients. And then repeat that same process. So bring down the first number. Then 1 times negative 5 is negative 5. Three times negative 5 is negative 15. And our remainder is 16. So therefore, we can say that p of negative 5 equals 16. Okay, so repeating the process for number 2. Our x is 3, so 3 goes in the box. Remember, if you're missing any terms, you need to fill in a 0, and this one's missing an x cubed. So we're going to just kind of fill in a 0 for x cubed. So we have a 1, then a 0, negative 5, negative 17, and negative 12. Okay. Okay, now repeating the same process, bring down that first number, then multiply by the number in the box. Okay. So the answer here is the remainder, which is negative 27. So p of 3 equals negative 27. Once you get the hang of it, yeah. It was weird, though. I've never seen, like, math done like this. It's weird.
I like this way a lot more.
What's that?
I like this way a lot more.
Yeah. As long as you can remember the steps. Okay. Number 3. we're going to do the same process. So with this one, the factor theorem, if there is no remainder, then yes, x minus 3 is a factor. If there is a remainder, then we're going to say no, it's not a factor. So we have the x minus 3, so we're going to take the opposite of negative 3 and just put positive 3 in the box, and then list out the coefficients. Yeah, it's tricky because if I zoom in, then people can't see the last. I don't know. Okay. So coefficients would be 1, 5, negative 17, negative 21. I bring down that first term and then multiply by the number in the box. And we get no remainder. My hand doesn't fit in here. Okay. No remainder. Yay. So that means yes, it is a factor.
Would there be problems like this in our homework where you have to like determine if it's a factor or not?
Actually, most of the homework problems are this for right now.
Oh.
Yeah, but same process. Number 4, same thing, x plus 3, so we're putting a negative 3 in the box and then factoring it out. Notice with this one, the terms are in the correct order, so I'm going to put them in the right order as I write it down. 2, then 3, then negative 8 times, and negative 12.
That's sequentially?
Yeah, from standard form. And 2. Remainder, sad face. So it's no, not a factor. Okay, next. In the next skill, we're going to factor it out completely. So we're going to divide by this factor that we're given, and then we're going to use the remainder to actually factor it out. If that doesn't make sense, I'll just show you what I'm talking about. So for number 5, same thing. We get this first factor, x minus 5. We're just going to put a 5 in the box, list out our coefficients. So these terms right here, this would be x squared, this would be x, the constant, and the remainder. There's no remainder here. So first we have the first factor of x minus 5, which we were given. And then after we factor that out, these are the leftovers over here, which would be x squared plus 3x minus 4. And then for this problem, they want us to also put this into 2 factors. So remember, when we factor, we need 2 numbers that multiply to this number and add to this one, like 4 and negative 1. So like x plus 4, x minus 1. Which one? Oh, it's supposed to be an x. I don't know. It's not a negative. Okay. It's just, yeah. But this is what they're looking for. Okay, number 6. Same thing here. We're going to factor out the x plus 3 and then determine the other two factors. So we'll put a negative 3 in the box. And then list out the coefficients. Then for this one, it would be x squared minus 25 because the middle term would just be 0x. And x squared minus 25 would just factor out to x plus 5, x minus 5. Okay, and one last page. So we're going up to number 7 now. Okay, if a polynomial has a root of a, then the factor can be written as x minus a. Okay, so for each one of these, we're going to do like x minus whatever that number is. So it would be like this, x minus 5, x plus 2, and x minus 3. Okay, and then from here, we're going to just like expand it. I'm going to FOIL these two, or factor them out, FOIL these two terms to combine them. So first, x squared negative 3x plus 2x minus 6. And then the next step, we're going to continue. When you have like a binomial and a trinomial, you take this first term, multiply it by all 3 here, and then we're going to take the second term and multiply it by all 3 here. So first one, x times x squared would be x cubed, minus x squared, minus 6x, plus negative 5 times x squared, did I miss? Okay, then combine like terms, so x cubed, negative 6x squared, and we're done. I'm going to stop there. So we're not going to do 8.
Where'd you get negative x?
Negative x squared? Or this here. Oh, negative 6x plus 5x. Okay, so for the rest of the class, I'm going to give you to do your homework. Like I said, the homework looks more like this, so use this as a guide. You're just looking for the remainder, and that would be like the solution. So keep that in mind. You can get up, get a laptop. Let me know if you have questions.